Today I'll be dealing with another example on nodal analysis with AC source including supernode. Here we have got the problem, find the voltage across the capacitor in the network shown in the figure. That is, we have to find V2. So how can we do that? There is a 12 angle 30 volt between V1 and V2, and there are two nodes. So we can first write the KCL for this supernode. KCL at supernode V1 and V2. We can write it as 2 angle 60 minus, that is moving into the node, plus V1 by 1J plus V2 by 2 plus V2 by minus 2J is equal to 0. Let it be equation number 1. And equation number 2 can be written as, here we have two unknowns and we need two equations to find the two unknowns. So we can write the second equation as V1 minus V2 is equal to 12 angle 30. That is equation number 2. So now we can go for the calculations. We can solve the equations by regrouping it. V1 into 1 by 1J plus V2 into 1 by 2 plus, minus minus 1 by 2J is equal to 2 angle 60 degree. We can write it as minus V1, 1 by 1J. When J goes to the numerator, it becomes minus. Therefore, we can write minus V1 into J plus V2 into 0.5 plus this minus, this J on going to the numerator will become minus. Therefore, we can write 0.5 plus 0.5 . J is equal to 2 angle 60. So we can convert this 2 angle 60 and 12 angle 30 to rectangular form for calculation. So 2 angle 60 degree in terms of rectangular, we can write it as 1 plus 1.7 J. We can find it using a calculator, and 12 angle 30 is equal to 10 plus 6I. So now we can calculate it as minus V1J plus V2 into 0.5 plus 0.5J is equal to 1 plus 1.7J, and V1 minus V2 is equal to 10 plus 6J. These are the two equations, and on multiplying the second equation by J, you can get the second equation. You will get it as minus V1J plus V2 is into 0.5 plus 0.5J is equal to 1 plus 1.7J, and the second equation we can write it as by multiplying by J, V1J minus V2j is equal to minus V2j is equal to 10j minus 6. So you can make the calculations as these two will get cancelled. Therefore V2 into 0.5 plus 0.5j minus j is equal to minus 5 plus 11.7 j. So you will get V2 as V2 is equal to minus 5 plus 11.7 j divided by 0.5 minus 0.5 j, and you will get the answer as minus 16.7 plus 6.7 j, and you can convert it into polar form, that is by using a calculator you will get it as 17.99 angle 158.13. That is the voltage across the capacitor, that is V2. We have to find V2, and that is the voltage across the capacitor. So you can solve it in another method also, that is we have got these two equations. By using a Cramer's rule we can get the result, and next I'll be showing you how we can find it using Cramer's rule. By using Cramer's rule, we can find it as, you can write the coefficients of the first equation, minus 1j, 0.5 plus 0.5j, 1 minus 1. This is the LHS of both the equations, V1, LHS coefficients, V1, V2 is equal to 1 plus 1.7j and 10 plus 6j. And to find V2, we can replace the second column with the RHS. V2 is equal to minus 1j. We can write this as same. And the second column we replace it by the RHS. 10 plus 6 j. The determinant of this divided by this determinant, this minus j, 1 0.5 plus 0.5j minus 1. Then you will get the numerator as 10 plus 6j into minus j minus 1 into 1 plus 1.7j, the numerator, and the denominator will have 1j. See, minus minus will become plus, minus 0.5 plus 0.5j. So we'll get the numerator as 5 minus 11.7j divided by minus of 5 minus 0.5j. that is equal to minus 16.7 J plus 6.7 I, which is equal to 17.99 angle 158.13. And this is the voltage across the capacitor. So I have shown you using both equation method and Cramer's rule method. So if you have any doubts, you can ask me.